Hey, we have a lesson here for you on geometric probability. Geometric probability is we're going to find the probability of things happening or things not happening using geometric shapes. So if we look here, the first example that we have, it says a 15 by 20 foot dining room of a house has original hardwood floors. In order to protect the hardwood floors, a 11 by 15 foot rug is laid in the dining room. What percentage of the hardwood floor is covered by the rug? Well, you can either start by drawing a diagram here of your situation, 15 foot by 20 foot, and then you're going to put a 11 foot by 15 foot rug in the dining room to protect the floors. And so by doing that, it says what percentage of the hardwood floor is covered by the rug. So is covered by the rug would be all of this area here. So when you find the probability of being covered, your favorable event would be the rug, and your total would be the room. And this is area of the rug and area of the room. And so you go ahead and calculate this. The area of the rug is going to be 11 times 15, which is equal to 165 square feet. And then you have the area of the room, which is going to be 15 by 20, which is 300 square feet. And so now area of the rug, 165 square feet. Area of the room, 300 square feet. The square feet will cancel each other out. So now we have 165 divided by 300. And when you type that in to find that percent, should be equal to 0.55, and you change it to percent, move it 2 places to the right, 55%. 55% of the room is being covered by the rug. Let's move on to the next one. If you feel like you want to pause the video and try and work these out and then check your solutions, you should go ahead and do that. This would be a good indicator of whether or not you understand this concept. So this problem here says ice cream in the cafeteria is made. Ice cream in the cafeteria is made in 4-gallon containers. Once the level gets below 0.5 gallons, the ice cream has a tendency to be watery. What is the probability that when you go to the cafeteria for your afternoon dessert, the ice cream machine will be below 0.5 gallons? Well, if we think about this, let me go ahead and show you a situation that we have here. Imagine you have the ice cream machine, it has 4 gallons, and you're trying to get ice cream, you don't want that last half gallon of ice cream. It's a little bit watery. So if we say, let's figure out what we're trying to find the probability of. What is the probability that when you go to the cafeteria for your afternoon dessert, the ice cream machine will be below 5 gallons, or not 5 gallons, will be below 0.5 gallons. So the probability that there is less than 0.5 gallons is equal to favorable over total. So if we think about this, if we're talking about less than 0.5 gallons, well, that would be all of this down here. That would be the 0.5 gallons. And what would be your total? Favorable over total is probability, so total is 4 gallons. The gallons cancel each other off, and now we reduce this. If we have 0.5, we can move the decimal one place to the right, move the decimal one place to the right, then we have to move the decimal for the 4 one place to the right. So now we have 5 over 40. And what number goes into 5 that also goes into 40? 5 does. But we're trying to find probability. So I guess we don't even need to reduce that fraction. If you find the percent, 2 places to make it a percent. So 5 over 40 is 0.125, and that would be 12.5%. You could have thought of this problem a little differently. If you look over here, I am breaking the 4 gallons up into equal parts. So how many parts do we have? Well, here would be 1 part, 2, 3, 4, 5, 6, 7, 8. There are 8 total parts, and if we're trying to find the probability of less than half a gallon, how many parts is that? Well, that would be 1 part, and that's 1 over 8. So that's also 0.125. And if you would have reduced 5 over 40 by 5, you would have gotten 1 over 8. So there's 2 different ways to think about this problem. Let's move on. Using the diagram below, find the probability that a randomly chosen point does not lie in the circle. You have to pay attention to words like that, does not lie in the circle. Well, we want to find the probability of not in the circle. So that would be the area that is not in the circle over top of the area of the rectangle. The area of the rectangle is fairly easy to find. The area of the rectangle, we're going to take 15 by 25, and 15 times 25 is going to be 375. So we have 375 square feet for the area of the rectangle. And how do you calculate the area that is not in the circle? Well, first off, let's go ahead and calculate the circle. the area of the circle. And the area of the circle, the formula for a circle is going to be pi times radius squared. That's the area formula for a circle. Well, it looks like the diameter is 10 feet, so the radius must equal 5. So we say pi times 5 squared, which is equal to 25 pi. Now, how do we find the area of the parts that are outside of the circle? How do we find that area of the parts outside the circle? Well, if you know the area of the rectangle, you know the area of the circle. All you have to do is subtract those. The part that is not the circle is going to be 375 minus 25 pi. And I should have put, for the circle, was 25 pi square feet. And you might be questioning why I have not changed this to 25 times pi, which is going to be some sort of decimal. Why I wouldn't change it to the decimal, and that's for the simple fact that 25 pi is the exact number here. And with modern technology, calculators now are able to do 25 times pi in them and give you an accurate answer. You don't want to change pi to 3.14 if the calculator has a pi button. Use the pi button for pi. You don't want to change it to 3.14 because your answers are a little bit off, because 3.14 is an approximation of pi. It's not exactly pi. So let's go up here and work out the probability of not being in the circle. Well, we know the area of not in the circle is on top, so we know that's 375 minus 25 pi. That's on top. And the area of the rectangle is on bottom, so that's 375. And we know both of these are going to be square feet. And I should have done that down here at the bottom. I should have put square feet afterwards. And the square feet cancel each other off. They cancel each other off. And let's go ahead and do that calculation. 375 minus 25 pi is approximately 296.46, and then I'm going to divide that by 375, and that is 0.7905. Move the decimal 2 places to the right, and we get 79 points, and this 5 rounds that 0 up to a 1. Approximately 79.1%. Now, if we go to the next slide here, the next slide says, using the diagram below, find the probability that a randomly chosen point will lie in the circle. So, probability that it lands in the circle is equal to the area of the circle divided by the area of the rectangle. The area of the circle is the favorable event. We're trying to land inside the circle. Area of the rectangle is the total. and that would be the total amount of space that we have there in the diagram. And I just copied and pasted our work from the last slide. And so the circle, the area of the circle is going to be 25 pi square feet. And the area of the rectangle is 375 square feet. You know, the square feet cancel each other out, and so now we're going to just type 25 pi divided by 375 in the calculator. And we get something like 0.2094. And when you move it 2 decimal places to the right, we're going to say it's approximately 20. The 4 does not round the 9 up, so it's approximately 20.9%. 20.9%. And if you notice, this is 20.9%. Back on the previous slide, we had 79.1%. If you take 79.1% and 20.9%, you add those together. 1 plus 9 is 10. Carry your 1. 1 plus 9 plus 0 is 10. Carry your 1. And 1 plus 7 plus 2 is 10. And so this is 100%. So the probability of landing in the circle plus the probability of not landing in the circle would be 100%, because that would be every part of the rectangle. So you put those two parts together, you get 100%, and this is how you can do some of your calculations if you know the probability of not landing in the circle. We could have taken 100% minus that 79.1%, and that would have given us the 20.9%, and it would have saved us from doing this calculation. Just could have saved us a step, but I wanted to show you both ways, give you practice on both problems, so that way you're aware of it. Let's check out the next one. At a carnival, you can win prizes if you throw a dart into the bullseye. Assume that your dart lands on the board and that it is equally likely to land on any point. Find the probability of hitting the bullseye. Well, we know that it's going to land on the board, and we are trying to find the probability of a bullseye. Well, on top you would have the area of the red bullseye, and on bottom you would have the area of the board, the whole board, the dart board. The area of the dartboard. All right, well, we know they're both circles. The bullseye and the whole dartboard are both circles. So let's go ahead and do some calculations. The bullseye is the area of the bullseye. It's pi times radius squared. Well, the radius looks like it's 1 inches. So, or just 1 inch, I guess. So that would be pi times 1 squared. And 1 squared is 1. So what's 1 times pi? That's pi. So the area of the bullseye is pi square inches. The area of the board is pi times radius squared. Well, the radius here, if each one of these rings is 1 inch. What's the total here? Well, here would be 1, 2, 3, 4, 5, 6 inches from the center of the bullseye clear out to the edge of the dartboard. So the radius is going to be 6. And pi times radius squared, 6 squared is 36 pi. So the area of the dartboard is 36 pi square inches. Let's move this out of the way so we can get some room. So let's go ahead and do our work. On the top, the area of the red bullseye, which is pi square inches. Pi square inches is the area of the bullseye, and the area of the dartboard is 36 pi square inches. Let's go ahead and do some reducing real quick. We know the square inches cancel each other out, and pi divided by pi, those also cancel each other out. And we can cancel those out because this is multiplication in between 36 and pi. If it was addition, we would not be able to do that. So what do we have left on top? Well, you might think there's nothing up there, but there's always a 1. Remember, it was in front of pi, there was the invisible 1, and on bottom, 36. So the probability of hitting a bullseye is 1 out of 36, and the approximation for that as a decimal, 0.2777. Change this to a percent by moving 2 places to the right. 27 point, and we notice this 7 will round this one up. 27.8%. And if you had done that one on your own, you would notice that I forgot 1 space in there. Let's try this again. 0.0277. That's much better. 2 places. So this is going to be approximately 2.8%. I had noticed that before I said 27.8% was the probability of landing in the bullseye, but 27.8% I know is about 1/4. And if you look at that red bullseye on the dartboard, that red bullseye does not look like it is covering up 1/4 of the whole dartboard. So I checked my calculations, realized that it was only 2.8%, and that's looks like the red bullseye is covering about 3% of the board. So make sure you're always thinking whether your percentage there is possible. And let's look at this one here. What is the probability that a randomly chosen point does not lie inside of the isosceles triangle? Okay, and we have a circle. The circle has that radius, or I'm sorry, it has the diameter of 30 meters. Well, if it has a diameter of 30 meters, what's the radius? The radius is 15. So let's go ahead and put the radius is 15 meters. All right, so we have to find the probability of landing where? Randomly chosen point does not lie inside the triangle. So we say not in the triangle. So on top, we will have the favorable outcome, which would be the area of not landing in the triangle. And on bottom, you will have the total area of the diagram, which is the area of the circle. Okay, well, let's go ahead and calculate the area of the circle. which is pi times radius squared, pi times 15 squared. 15 squared is 225 times pi. And since this is meters, the area of the circle is going to be 225 pi square meters. And let's do the area of the triangle. Let's do the area of the triangle. Well, we know the formula for a triangle. You can think of it as two different ways. Base times height divided by 2, or 1/2 base times height. However you want to think about it. So let's go ahead and say 1/2 base. The base is 30 times the height. What's the height? Well, since this is an isosceles triangle, we know that from the midpoint of this side to there is going to be the height. And you notice that the midpoint is also the center of the circle, and this vertex of that triangle lies on the edge of the circle, so therefore this is the radius of the circle, which is also 15. So let's go ahead and multiply these. 1/2 of 30 is 15, and we have 15 times 15, which is 225 square meters is the area of the triangle. And let's go ahead and do our calculations here. The area of not landing in the triangle is going to be the whole circle, the area of the whole circle, minus the area of the triangle, square meters. And so that's what we put up here. 225 pi minus 225 square meters. And on the bottom we have the area of the circle, 225 pi square meters. And you notice that in this area of not the triangle, this pi, 225 pi and 225, they are not like terms, so you cannot subtract those and say that that's 0 pi, because in order to do that, this 225 would have to have a pi with it. Okay, those are not like terms, so you just, when you go to combine like terms using pi, everything has to have a pi with it in order to combine it. It's kind of like when you're using variables x and y. Let's go back to our fraction up here. We know the square meters cancel each other out, and so we can go ahead and do our calculation here to find our probability. If we have 225 times pi and we subtract 225 from that, you should get approximately 481.86. And then when you divide that by 225 pi, so when you go ahead and do that, give me one moment here. Okay, and when you do that, you say 0.0 6816 is what you should get. Move your decimal place 2 places to the right, so that'll be 68.6. Rounds the 1 up, do a 2. So it is approximately 68.2% of the circle is not covered by the triangle. Well, that's all we have for today for this lesson. If you have any questions, let me know, and I can try and answer this for you.